Am I audible? Am I audible? Reply. Am I audible? So we'll do uniform circular motion. Uniform circular motion. Okay. So okay, am I audible? So it is in 2D motion only. Okay. When we'll say uniform circular motion, it will be 2D motion only. Motion in a plane. Correct? Motion in a plane. Okay. Okay. Now we'll discuss about uniform, the definition of uniform circular motion. So what will be the definition? If if a particle moves along a circular path with a constant speed, its motion okay, then its motion is said to be a uniform circular motion. Okay. Therefore what we can say about this? Yes, speed is the magnitude, na, velocity, I am not talking about velocity, Agnibo. I am talking about the speed, the scalar quantity, isn't it? Correct? Okay. Therefore, there are certain examples. Number one, motion of the tip of the second hand of a clock. Number two, motion of a point on the rim of a wheel rotating uniformly. Correct? So these are the two examples of it. Okay. Now a frequently asked question is there. Justify that a uniform circular motion is an accelerated motion. Okay. So to answer the question, first you draw the diagram. Okay. Now you see the diagram. Here it is the center, correct? Now on this point, if it is point A, this is point B, and this is point C. Okay. Now if I draw a tangent on point A, on point C, on point B, okay, and then we denote the velocity with this vector quantity, and you can see the direction is getting changed, and this O to A or O to C is actually the radius vector. Okay, correct? Correct? Yes or no? So here also there should be another, direction of the velocity. Here should be another direction of the velocity. So you can say the magnitude of this quantity is actually will be the constant quantity, but the direction get changed. Therefore, if the direction change, that means the velocity get changed. Correct? The velocity get changed. So therefore, what you can say, if there is a change continuously in the direction of the velocity, therefore that should be the change of the velocity. And if the change of the velocity occurs continuously, then you should say uniform circular motion is an accelerated motion. Correct? Uniform circular motion is an accelerated motion. Correct? Correct? Clear about it? Okay, बताओ बताओ सही से, ठीक है ना? Clear about the answer of it? Just give me a reply so that I can understand that this basically message is passed to you. Wishi and others. Ognivo. Okay, clear about it? Okay, now moving to the next concept. There are certain terms to define in this specific resume of motion. Like when I say specific resume of motion means this uniform circular motion, a specific condition. So there are certain terms like angular displacement, angular angular displacement, angular displacement. What do you mean by angular displacement? Angular, what is angular displacement? Angular displacement of a particle which will be moving along a circular path is defined as the angle swept out by its radius vector in the given time interval. Yes, correct? Correct. So let me write the definition for you. It is defined as the angle swept out by its radius vector in the given interval of time. So that is your angular displacement. Then how we should basically represent the angular displacement? Okay, there must be some representation of angular displacement. Okay, okay, so how to represent it? See, again we should produce a diagram where there will be a circle, because here all the things we should consider the path should be circular, isn't it? So first let us draw a circle. Then this is the origin of that circle. Now suppose the circle having a initial position, this P naught, okay, and from suppose a position on this path, like A, it is nothing but it is an angle which made with that x-axis. Okay, maybe it is theta 1. This angle is theta 1. Okay, now let's suppose another position on the same path. Another positions means what? What do you understand by another position? Another position means the same circle. If you just see, I basically denote it with the green point. If the same point travels across this path, and if it reaches here, and if I name it point B, and if I draw a join O and B, and it will make an angle theta 2 with this OP naught. Okay, now what I should basically get, I should get the displacement from A to B, displacement from A to B, and that should be delta S. Okay, so that means this is a displacement across the path, circular path. And then what will be the change of this angle? What will be the change of this angle? This delta theta. Delta theta is equal to theta 2 minus theta 1. Okay, theta 2 minus theta 1. So that means this delta S is actually the displacement along this circular path A to B, where this delta theta is nothing but the delta theta means this angle, na? If I denote, it is this angle actually, this angle, isn't it? This is actually your delta theta, only this portion. Okay, now what I can say, I can say another one thing, that is, if the time interval, let's suppose initially when it reaches A point, it is at t1 time, at B point it is t2 time. So time interval delta t is nothing but t2 minus t1. Okay, and therefore what I can say, I can say this delta theta is equal to delta S by this R. R is what? This OB is also R, OA also R. Okay, so angle is equal to arc by radius. Okay, now okay, correct? Do you understand? Do you understand about it? Just reply me. Hello. Ognivo. Ishan, okay. Shujoy, okay. Okay, that means you are getting the point. Okay. Jessica join नहीं किया ना? अच्छा. Okay. Now, see what will be the unit of this angular displacement. That means this delta theta. The unit should be in radian. Radian. Okay, and it is actually, this thing is actually dimensionless quantity. Dimensionless quantity. Okay, now moving to the next concept, that is angular velocity. That is angular velocity. Angular velocity, which is denoted by omega. Okay, now here what will be the definition for this particular parameter? The time rate of change of angular displacement, or the change of angular displacement with respect to time, is called angular velocity. Okay, So of a particle is called its angular velocity. Okay, so naturally it should be omega, that is equal to delta theta by delta t, or you can say it is d theta by dt. Okay, and the unit should be radian per second. Okay, and dimension should be correct. Okay, now my now the voice is clear now. अब देखो वॉइस क्लियर है कि नहीं है, बताओ, सही से बताओ, वॉइस क्लियर है? हेलो, देखो वॉइस क्लियर है अभी? वॉइस क्लियर है अभी? जल्दी जल्दी बताओ। ठीक है, ये समझ में आया एंगुलर वेलोसिटी, इसका रिप्रेजेंटेशन, यूनिट, डायमेंशन। ठीक है ना? Okay, now definitely there will be another term that is known as instantaneous angular velocity. Okay, so that means when this delta t tends to 0 at that time interval. Okay, so it should be represented is equal to limit delta t tends to 0. You know already about instantaneous speed, instantaneous velocity, instantaneous acceleration. The same concept is here. Okay, clear? Clear or no? Clear? Clear or no? बताओ, बताओ। ঐশী, অগ্নিব, okay, now time period. This is another term, time period. Time period. So the time taken taken by a particle to complete one revolution along its circular path is called its period of revolution is called its period of revolution, and it is denoted by capital T. Capital T, and definitely it will be measured in seconds. Correct? Okay. Now the next thing, that is frequency. 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 The frequency of an object in circular direction, circular path, is defined as the number of revolution completed per unit time. Okay. So it is defined as the number of revolution completed per unit time, when traveling along a circular path. So that is actually frequency. Okay, it is denoted by nu, that is nu. Okay, and basically time period is equal to, time period you know already, time period is equal to 1 by nu. So nu is equal to 1 by time period. So the unit of this nu should be second inverse. Okay, so time period is in second, so frequency will be second inverse. Okay, correct? Clear? Now we'll see a relation. Now we'll see relation between omega, nu, and then t, time period. We'll see the relations between all of them. So angular velocity, frequency, and time period. Okay. So relation between omega, nu, and capital T. Okay. Acha. Now you see one thing. By definition of the time period, what is its definition? A particle completes one revolution in capital T time, isn't it? So a particle completes one revolution in capital T time. Okay, that means what? One revolution means what will be the path of what will be the path which will be traveled by the particle in one revolution? Is it if you see the total path, so it should be, so it transverses it transverses an angle of in one revolution. What will be the angle? 2 pi angle, 2 pi. So so it transverses an angle of 2 pi radian in capital T time. Okay, so we know what we know. Theta is equal to 2 pi radian. So d theta over here. Okay, so angular velocity omega is equal to this angular displacement by time. So 2 pi, here the small t is actually replaced by capital T because the time period is, so time is actually the total the time period. Okay, now what we know about time period? Nu is equal to, frequency is equal to 1 by t. So here in 1 by t I'll place the nu. So omega is equal to 2 pi t, 2 pi divided by t, or 2 pi nu. This is the relation. Okay, one relation, omega is equal to 2 pi by t. This is one relation. Another relation, omega is equal to 2 pi into nu. Correct? Tell me, आया समझ में? बताओ. Now you see one thing, there is another question that can be asked, that is the relation between linear velocity and angular velocity. Let us discuss the question. Let us first draw the diagram. One circular path. First you produce the circular path. Okay, so the circular path. Now this is the center. Now if suppose it travel from point A to B, now the difference between A to B, if you see the circular path, so that is actually delta S. Okay, along the path, and the theta, the angle is delta theta, and this radius, this is the radius vector, here also are. So we know delta theta is equal to delta s by r. Okay, now what we should do, we have to divide both the side with delta theta, delta t. So dividing both sides by delta t. Okay, then what you will get, delta theta by delta t is equal to 1 by r is will be there, so delta s by delta t. Okay, now taking delta t tends to 0, so both the side, so limit delta t tends to 0, delta theta by delta t is equal to 1 by r, limit delta t tends to 0 into delta s by delta t. Okay, but we do know one thing, हमें क्या पता है, हमें इस चीज के बारे में पता है ना, ये क्या होता है, दिस इज बेसिकली योर इंस्टेंटेनियस angular velocity, isn't it? Instantaneous angular velocity. Angular velocity. So this has to be replaced with omega. You can write instantaneous or you can leave it like this, omega, and here it should be 1 by r. This portion is nothing but instantaneous linear velocity. Instantaneous linear velocity, because it is delta s by delta t. Okay, so limit t tends to 0, delta s by delta t is nothing but instantaneous linear velocity. So you have to replace it with v. Okay, linear velocity na, replace with v. Okay, therefore v is equal to r omega r. So what I can say, linear velocity is equal to angular velocity into radius, or you can write radius into angular velocity. Okay, now in vector notation, it should be correct. Okay, बताओ, ठीक है ना इतना तक? ठीक है ना? अब हम लोग नेक्स्ट टॉपिक में जाते हैं. इतना तक पता चला ये वाला कैसे ये प्रूफ हो रहा है? Okay, now we'll see angular acceleration. Angular acceleration. Acceleration. Angular acceleration. Angular acceleration. So angular acceleration is denoted by alpha. Alpha, and which is equal to change of angular velocity with respect to change in time. So the time rate of change of angular velocity of a particle change of velocity of a particle is called angular acceleration. Angular acceleration. Okay, so if it is angular acceleration, there must be another thing like instantaneous acceleration, angular acceleration. Okay, and that should be denoted alpha instantaneous is equal to limit delta t tends to 0 delta omega by delta t. This is the instantaneous acceleration, angular acceleration. Angular acceleration. Okay, now what will be that, then what will be the unit, like radian per second square, and the dimension must be m raised to the power 0, l raised to the power 0, t raised to the power minus 2. Okay, and as we know the relation between linear velocity v and angular velocity omega is equal to v is equal to b is equal to omega r. Okay, or r omega, we know it. Okay, therefore what we can do now, in this relation, if you differentiate both the end with respect to t. So it should be dv by dt is equal to ddt of r omega or omega r, then because r is constant, so it should be r out of it, so d omega by dt, that is equal to dv by dt, and therefore we know this quantity d omega by dt is nothing but alpha, and dv by dt is a, acceleration is equal to r into alpha, okay. So what you can say, linear acceleration, this a is what, linear acceleration, and this is angular acceleration. So linear acceleration is equal to radius into angular acceleration, okay, and it should be represented in this form, a in vector form, this is in vector notation, it should be a near alpha cross r. Clear? Na? Clear up to this? Hello? Okay, so shall I proceed to the next topic? Okay, now here we do have concept of centripetal acceleration, and also there must be a derivation of the expression for the centripetal acceleration of a particle which will be moving with a uniform speed of v along a circular path of radius r, and discuss the direction of its motion, of its acceleration also. Okay, so what do you mean by centripetal acceleration? So centripetal means towards the center, okay. So the definition for this, centripetal acceleration, when a body is in uniform circular motion, its speed remains constant as we know, but velocity changes. Okay, now the velocity change continuously, and due to the change of its direction, due to the change of its direction. Okay, now as the you can see there is a change in the direction of the velocity, therefore the velocity gets changes, hence the motion is accelerated. Therefore hence you can say hence the motion is accelerated. Hence the motion is accelerated. Okay, hence the motion is accelerated. Okay, so a body undergoing uniform circular motion is acted upon by an acceleration directed along the radius towards the center. Towards the center of the circular path. Okay, now this acceleration is called centripetal, or it is center seeking, centripetal towards the center. Okay, acceleration. So therefore what I can say कि when a body is in uniform circular motion, अगर यूनिफॉर्म सर्कुलर मोशन में है तो उसका स्पीड तो मैग्नीट्यूड जो है कांस्टेंट है, लेकिन जो डायरेक्शन चेंज हो रहा है इसके लिए वेलोसिटी कांस्टेंटली कंटिन्यूअसली चेंज हो रहा है. तो चेंज हो रहा है, इफ देयर इज अ चेंज ऑफ द वेलोसिटी देयरफॉर इट इज एक्सेलरेटेड, and a body undergoing this uniform circular motion acted upon by an acceleration which is directed along the radius. वो जो सर्कुलर पाथ का रेडियस है उसी का along that radius it will, and towards the center of the circular path that acceleration will act, and this acceleration is known as centripetal or center seeking. Okay, correct. Then what will be the expression for the centripetal acceleration? See, here there is a consideration. Let us first consider a particle is moving along a circular path. So this circle roughly denotes a particle which will be moving along this circular path. If this is the center, and now here if I denote 2 points, one is Q, another is P. Suppose from the P point it goes towards the Q point. So this is the radius vector R. Here it is the same thing. Okay, and if this is delta theta, therefore, and if along on the point P, if I draw a tangent which will give the direction of the velocity at that point, and along on the point Q if I draw another tangent, so v2, velocity on at that point q. Okay, so and if this is the delta s, okay, this is the delta s, okay, and let's suppose uh, at t time particle is at point p at t time, and it reaches at q point at t plus delta t time, so the time difference is delta t. Okay, now to determine the change in the velocity, take external point, take an external point a here. Okay, and now what we should do, we should draw a line AB which is equal and parallel to V1. So this is your V1, you see this is your V1, this tangent, this is your V1. Now what you should do, take a parallel and equal line, so it is almost parallel and equal to that V velocity, and name it AB, and this is the same as your V1. Okay, now again from point draw AB that is equal and parallel to V1, and from point A take another AC. AC means which will be equal to this V2, this one, so this is AC. Okay, V2, correct, done. So this point is C. Okay, clear. Now just join B to C. Okay, and this will be the change, or here if you apply the triangle law of vector addition for this triangle, which one, BAC, then we know AB, this is one vector AB plus BC. See AB, see the head position of the vector A towards B, and BC the vector is towards C, so AC is basically taken the closing end of the triangle in opposite order, which will be basically the representation of the triangle law, correct. Therefore BC is equal to AC minus AB, correct, correct. So AC is representing V2 while AB is representing V1, and therefore BC will represent delta V. Okay, clear up to this, clear or not, tell me. Up to this it is clear. Okay, okay, where is Ognivo? Now if this delta t, you see the change of the this delta t, time change of the time, okay, it is from t1 plus delta t like that. So if delta t is very small, if delta t is small, if delta t is small, okay, then the chord PQ So which one is the chord? This one is the chord. You know already about the geometry. The chord PQ becomes equal to the arc PQ. So this is true for very small value of delta t. Very small value of delta t, for very small value of delta t, you can say the PQ, the chord PQ is denoted by the green line, is equal to the arc PQ, that is the red line thing, that arrow provided over here. So it is in green line and it is in red line. Okay. 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 Now you consider from the main diagram, consider triangle OPQ. Triangle OPQ. Triangle OPQ. This is also a triangle, na? Triangle OPQ. Okay. And in this triangle OPQ, triangle POQ, triangle POQ is equal to the triangle BAC, is equal to the triangle BAC. Now in triangle BAC is here for that for triangle OPQ, the angle POQ is equal to the angle BAC. Now this angle BAC is for the triangle BAC. Okay. Now we are comparing these two triangles, triangle OPQ in this diagram and triangle BAC of this diagram, and we are comparing the both the angles. Okay. And both of them are actually delta theta. Both of them are actually delta theta. Both of them are delta theta. Okay. And when the angle between the radius OP and OQ, this that means delta theta. When this angle between this radius OP and OQ is same as the angle between tangent P and Q. Tangent P and Q means this. So what they are saying, if these and these are equal, when both of them are equal, then you can understand another thing also. OP is equal to OQ is equal to R. OP is R, OQ is also R, same radius. Okay. And for the triangle BAC, you see AB is equal to AC, AB is equal to AC is equal to the V. Now if you say, sir, this is V1, AB was V1 and AC was V2, then how you can say both of them are equal? The thing is that their magnitudes are equal. So I have not given here any kind of vector sign. So this is simply their magnitude. So what I am considering? I am considering mod of V1 is equal to mod of V2 is equal to V. This is what I am considering over here. Do you understand about this? Are you getting my point? बताओ, पॉइंट समझ में आया? सही से बताओ. पॉइंट समझ में आ गया है ना? ओके ओके. देयरफॉर अगर ये वाला चीज समझ में आ गया तो हम लोग एक काम कर सकते हैं. इसमें जो पीओक्यू मतलब ये वाला डेल्टा थीटा था एंड जो बीएससी वो भी डेल्टा थीटा था, ठीक है. तो ट्रायंगल ओपीक्यू या फिर पीओक्यू जो एंड ट्रायंगल बीएससी, इन दोनों में POQ इज इक्वल टू BAC, ठीक है। एंड हमें ये भी मिल गया कि अगर ये दोनों ट्रायंगल में हम लोग ये चीज़ देखेंगे, क्योंकि वो उसका इक्वल हो रहा था ना, मतलब चीज़ को समझो एक बात, जैसे हम लोग वो दोनों को इक्वल कर रहे थे और ये टेंजेंट को भी हम लोग इक्वल दिखा रहे थे, ठीक है ना, दो ट्रायंगल के बीच। मतलब हम लोग दिखा रहे थे कि OPOQR जो रेडियस ऑफ द सर्कल के बराबर है, और उसमें मैं दिखा रहा था जो ये वाला ABAC इज इक्वल टू V, मतलब AB और AC इक्वल है। तो दो ट्रायंगल जिनका दो साइड, मतलब अगर तुम्हारे पास दो ट्रायंगल है, उसका दो दो करके जो साइड है, मतलब उसका ए साइड ए दूसरा ट्रायंगल का ए साइड के साथ, उसका बी साइड दूसरा ट्रायंगल का बी साइड के साथ, ये और उसके अंदर वाला जो एंगल है, मतलब दो साइड का अंदर वाला जो एंगल है, मतलब ये साइड, मैं सही से देखो, ये साइड एंड ये साइड किसके साथ है, ये साइड एंड ये साइड के साथ इक्वल है, दोनों के बीच एंगल जो है वो भी अगर इक्वल है, ये अगर कंसीडरेशन है, तो मैं बता सकता हूँ ना ये दो ट्रायंगल जो है सिमिलर टाइप ऑफ ट्रायंगल है, सिमिलरिटी रूल, सिमिलर ट्रायंगल है, सिमिलर ट्रायंगल है। सो सिमिलर ट्रायंगल में हम लोग क्या बता सकते हैं, PQ बाई OP, PQ बाई OP, मतलब वो डेल्टा थीटा का दो साइड का, मतलब डेल्टा थीटा का दो साइड का जो दो साइड, मतलब दो साइड है उसका दो डायरेक्शन में दो साइड जो है PQOP, दैट इज इक्वल टू BC बाई AB, करेक्ट। देयरफॉर डेल्टा S बाई R इज इक्वल टू डेल्टा V बाई V। सो PQ क्यों डेल्टा S हुआ, क्योंकि मैं बताया था ना कि जब ये कंडीशन है, इफ डेल्टा T इज वेरी स्मॉल एंड तो कॉर्ड PQ आर्क PQ के बराबर हो जाएगा। ओके, सो PQ इज इक्वल टू डेल्टा S, और OP था R, और BC था डेल्टा V, और AB था V। ओके, तो यहां से डेल्टा V इज इक्वल टू V बाई R इंटू डेल्टा S, ठीक है, क्रॉस मल्टीप्लाई किया। नाउ डिवाइड करो बोथ द साइड विथ डेल्टा T, डिवाइडिंग both the side with delta T, what you will be getting, delta V by delta T is equal to V by R delta S by delta T, correct। now दोनों तरफ taking the limit delta T tends to 0 on both side, on both side, what you will be getting, will be getting limit delta T tends to 0 डेल्टा V बाई डेल्टा T, दोनों तरफ मैं ले रहा हूँ वो वाला, इज इक्वल टू V बाई R तो कांस्टेंट है उसको ऐसा रखो, और लिमिट डेल्टा T टेंस टू 0 इस तरफ भी लिखो, और डेल्टा S बाई डेल्टा T, इसमें क्या आ जाएगा, डेल्टा V बाई डेल्टा T जो ये वाला पोर्शन है, और लिमिट लगा के ये आ जाता है इंस्टेंटेनियस एक्सेलरेशन, ये एक्सेलरेशन ये लिखो, लेकिन ये लीनियर है, dv बाई dt है ना, और v बाई r ये वाला आ जाता है जो तुम्हारा ds बाई dt जो आ जाता है, दैट इज जो लीनियर वेलोसिटी v, एक्चुअली इंस्टेंटेनियस होता है, लेकिन हम लोग अभी दोनों तरफ इंस्टेंटेनियस है तो नॉर्मल कॉन्सेप्ट से सोच रहे हैं। तो लीनियर एक्सेलरेशन इज इक्वल टू ये वाला जो है, लीनियर एक्सेलरेशन इज इक्वल टू v बाई r इंटू v, सो लीनियर एक्सेलरेशन इज इक्वल टू v स्क्वायर बाई r। therefore what you can say कि a is equal to v square by r, नाउ ए इज इक्वल टू वी के जगह लिखो, हमें ऑलरेडी पता है लीनियर वेलोसिटी इज इक्वल टू आर ओमेगा, तो हम लोग उसको लिख देंगे वी स्क्वायर की जगह आर स्क्वायर ओमेगा स्क्वायर बाई आर। देयरफॉर व्हाट यू कैन से ए इज इक्वल टू आर omega square, so I can say it is a is equal to omega square r. So this is the relation, this is the relation between the linear acceleration, angular velocity and radius of the circular path on which the object is traveling. Correct? Yes or no? आया समझ में? आया समझ में? Now you see one thing is there, सर्कुलर मोशन में जब वेरिएबल स्पीड होता है ना, यूनिफॉर्म स्पीड नहीं बोल रहा हूं, वेरिएबल स्पीड होता है, पार्टिकल मूविंग अलोंग सर्कुलर पाथ विथ वेरिएबल स्पीड, तब उसमें ना हम लोगों को दो एक्सेलरेशन दिखता है, दो एक्सेलरेशन दिखता है। सही से देखो, पाथ को सही से देखो, तब दो एक्सेलरेशन हमें दिखता है। क्या दिखता है? दो एक्सेलरेशन दिखता है। एक दिखता है, ये अगर मेरा एक पॉइंट है, ए पॉइंट में ले रहा हूं, इसमें अगर टेंजेंट खींचूंगा, सो आई विल बी गेटिंग टेंजेंशियल एक्सेलरेशन ए टी, एंड ऑल्सो I will be getting towards the center radial acceleration. ये center है ना O, तो that will be radial acceleration. But this is the condition when the particle is moving with variable speed, not constant speed, variable speed. उस condition के लिए याद रखो ये वाला चीज, variable speed के लिए। और ये दोनों acceleration का, दोनों acceleration ये जो AT है, tangential acceleration, that is equal to dv by dt, or it can be written as r alpha। और जो रेडियल एक्सेलरेशन है that is equal to, रेडियल जो है ना उसको हम लोग सेंट्रीपिटल एक्सेलरेशन भी बोलेंगे, रेडियल एक्सेलरेशन को हम लोग उसको और AC सेंट्रीपिटल एक्सेलरेशन भी बोलेंगे, that will be equal to v square by r. Okay, and the resultant acceleration will occur somewhere over here, as you know the concept of vector. This will be the resultant acceleration, and as per the concept of the resultant, as it is somewhere look like as, you know, because the components are making a square, so it should be A is equal to, because there is, if two components are there and the angle between them is 90 degree, so directly you can write this resultant acceleration is nothing but a t square, square root of at square plus ar square. Ar square is nothing, ac square. Okay, so this is the resultant acceleration of the particle, resultant acceleration of the particle in this case when the particle is moving along a circular path of radius r with a variable speed of v. Clear? Okay, clear? क्लियर और नॉट? बताओ, बताओ सही से, आया समझ में? सही से बताओ, तुरंत लिखो। तो हम लोग एक दो प्रॉब्लम देख के इस सेशन को वाइंड अप करेंगे जहां से क्वेश्चन आता है। ओके, एक प्रॉब्लम देख लेते हैं। A body of mass 10 kg revolves in a circle of diameter 0.4 meter, making 1000 revolutions per minute. Calculate its linear velocity. Velocity and centripetal acceleration. So centripetal acceleration is meant the radial component, na? You know it is AC, that is v square by r. You can write it is v square by r also. We can see over here, or you can say it is v square by r means nothing but it is r omega square also. Okay, so m is equal to 10 kg, r is equal to 0.20 meter, v is equal to 1000 by 60. So sorry, it is actually given because 1000 revolutions per minute, na? So 1000 revolution divided by 60, but it is actually, it is not, it is frequency, 1000 revolutions, so it is frequency. You can say it is f also, nu or f. You can write it is nu or f. Okay, so therefore what you can say, it is 1000 by 60. Okay, now angular speed omega is equal to 2 pi nu. We know about this relation 2 pi nu, right? So 2 pi nu is given, actually we found it out because 1000 revolutions per minute बताया ना, इसीलिए मैं nu को लिखा, क्योंकि nu क्या है, फ्रीक्वेंसी है ना, नंबर ऑफ रिवोल्यूशंस पर यूनिट टाइम. सो पर मिनट, इसलिए मैं क्या लिखा, 60 सेकेंड किया, 1000 बाई 60 किया ना, पर मिनट बताया तो 60 सेकेंड को रिप्रेजेंट किया, तो इसीलिए न्यू इजिकल टू 1000 बाई 60, और इसमें ये ऐसा करके हो जाएगा. सो इट विल बी 100 पाई बाई 3 रैड पर second. 100 pi by 3 rad per second. Now what will be the linear velocity? Linear velocity is what? V is equal to r omega, or r is equal to 0.20 into omega is equal to 100 pi by 3. We got it. So it should be 20 pi by 3 meter per second. Now what will be the centripetal? So this is about the linear velocity. Now then tell me what will be the centripetal acceleration. What will be the centripetal acceleration? Centripetal acceleration is nothing but AC. It is either you can write it is v square by r, or v square by r is nothing but you got 20 pi by 3 whole square by r. R is what? R is 0.20, so it is 20 into 20, it 400 pi square by 9 divided by 0.20. Okay, therefore it should be 400 pi square by 9 into 20 into, so so 4000 pi square by 9 into 2, so you can do it is 18. Okay, or you can write it is 2000 pi square by 9 meter per second square. So that is the centripetal acceleration in this case. Do you understand? Do you understand the concept? Hello? Yes, linear velocity it is 20, yes, pi by 3, yes, correct. So centripetal acceleration, how it comes, or you can do in this way also. It is actually, you can see this one, we can do r omega square. Okay, r omega square. So here it is 0.20 into omega square, that is 20 pi by 3 whole square. Okay, so therefore the same thing, so acha 20 square it is there. If I do in that way, acha omega, just a second, yes, omega was, sorry, omega was actually 100 pi by 3 na, sorry, it was 100 pi by 3, so it will be 100 pi by 3, 100 pi by 3. So 100 pi by 3 means here you can write it 100 into 100 to pi square by 9. Yes, now you can do this thing. Okay, and that should be 2000 pi square by 9, so that is meter per second square. Yes or no?